Alright, this is a video on how particle motion is actually tested on the AP. This is started out as an old free response question, and I just went ahead and put basically everything they could possibly ask you on it. It says, find the displacement of the particle during the first 4 seconds. A particle moves on the x-axis at its position at time t is greater than or equal to 0 is given by this formula. Displacement is defined as the distance. Like if it starts here and it moves 4 seconds, the displacement is how far did it go. So you just do x of 4 minus x of 0. And if you're going to be using the same thing over and over again, the best thing to do is to define, menu actions define, x of t to be 4t cubed minus 18t squared plus 15t minus 1. 4t cubed minus, does anybody see what I forgot to do? That whole thing is inside my parentheses. Sad. Let's see. Yay! Okay, it fixed it. 4t cubed minus 18t squared plus 15t minus 1. Enter. And it's done. And now if I want to find x of 4, it's 27. It just fills it in for me. So 27 minus, I can tell that x of 0 is going to be negative 1, but I'm just going to fill it in just to show that it actually does work. Minus negative 1. So my displacement is 28, and that is going to be in meters. Find the average velocity during the first 4 seconds. Remember that average velocity is f of b minus f of a over b minus a, or in this case, x of 4 minus x of 0 over 4 minus 0. When you see the word average, you think slope. So I know that x of 4 minus x of 0 on the top is 27 minus negative 1 over 4 minus 0. So that's 28 over 4, and that's meters per second, which ends up being 7. So he's going an average of 7 meters per second. Kind of like if it took me an hour to get to school, and I lived 60 miles away, I would say I was going an average of 60 miles an hour. I may have been going faster, I may have been going slower, but my average was 60 miles an hour. So his average was 7 meters per second. What is the instantaneous velocity at t equals 4? When you think instantaneous, you think derivative. So I want to find x prime of 4. So I'm going to do x prime of t. And if you scroll back up, the derivative of this would be, you can look at your paper. I'm going to do mine. I'm just going to look at my paper and do it. 3 times 4 is 12t squared minus 2 times 18 is 36t plus 15. And then I fill in 4, so 12 times 4 squared minus 36 times 4 plus 15. I don't know what that is. Or, so if this is a calculator, oh, it says no calculator. This totally says no calculator. Yeah, and I'm using my calculator. That's very bad. I should not do that. But I'm just so lazy. Yeah. No, I'm not going to use my calculator. I'm going to be good. I'm going to figure it out for myself. 4 squared is 16. 12 times 16 minus 36 times 4. Yeah, I don't know what this is. I'm using my calculator. 12 times 16 minus 36 times 4 plus 15 is 63. So he's going 63 meters per second at time 4. Find all values of t for which the particle is moving to the right. Justify my answer. Well, what I need to find is moving to the right. My justification is that I want to know where the velocity is greater than 0. Well, do I have a formula for the velocity? Yes. It's 12t squared minus 36t plus 15. And, I have to factor this. 12 times 15 is 180. What multiplies to give me 180 and adds to give me 36? Yikes. 6 and 30. Ha! Negative 30 and negative 6. So that's 12t squared minus 30t minus 6t plus 15. Group. I can take out a 3t, so that's 4t minus 10. Hey, I can obviously take something bigger than 3. I can take 6. 6t, and that's 2t minus 5. That looks better. Minus 3, 2t minus 5. So 2t minus 5 and 6t minus 3. Oh, by the way, I want to find out where this is greater than 0. That might have been helpful. So I've got 5 halves, and 3/6 is otherwise known as 1/2. And then I just realized that I could have factored out a 3 at the beginning and made my life a whole lot easier. Whoops. Oh well. So guess what we're going to do here to figure out where it's greater than 0? It's our good friend, the sine graph. 5 halves. Hopefully you remember how to do a sine graph. 6t minus 3. So remember, it changes at 5 halves, changes at 1/2, so that's positive, negative, positive. So where is it positive? Well, it's positive here and here. So it's positive from 0 because my time starts at 0, way up here. So it's positive from 0 to 1/2 u from 5 halves to infinity. Did it give me a stopping point, a high end? No, it did not. And find the position of the particle when the particle is at rest. Well, when is the particle at rest? When velocity is equal to 0. Well, velocity is equal to 0 at t equals 5 halves and t equals 1/2. So if I want to find the position, I want to find x of 5 halves, and I want to find x of 1/2. And even though I'm not supposed to use my calculator, I'm crunched for time on this video because it is 1:28 and y'all are coming in 7 minutes, and I'm hoping I'm going to finish. And then x of 5 halves. So 5 halves and negative 27 halves. So this one was 5 halves, and this one was negative 27 halves, and that is meters. Find the intervals of time when the particle is speeding up. Now, the particle is speeding up when velocity and acceleration have the same sign. So I have my formula for velocity, okay? This is my velocity sine graph right here. So I'm just going to go ahead and bring it down because I know that's 1/2. That's 5 halves. It's positive, negative, positive. And I need to find my acceleration. Well, my acceleration is my derivative of velocity. Well, my velocity, if velocity is 12t squared minus 36t plus 15, that makes my acceleration, 2 times 12 is 24, t minus 36. I would need to set that equal to 0. 24t equals 36, divide by 24, divide by 24, 36 divided by 24 is 1.5, so t is 1.5. So if we did a sine graph for acceleration, and 1.5 is actually 3 halves, so let's put it right here, and this is my acceleration sine graph. And I pick a number less than 3 halves, 0, and I fill it in. 24 times 0 is 0, minus 36 is negative, bigger than 5. 24 times 5 is bigger than 36, so that's positive. So where are the signs the same? Well, it's positive and negative. It's negative and negative right here. And it's positive, positive right here. So it's between 1/2 and 3/2, and also bigger than 5/2. I don't know if that made any sense or not. I hope so. Find the time when the particle changes direction. The particle changes direction when velocity changes sign. Velocity changed sign at, if we go back up and look at our sign graph of velocity, at 1/2 it changed from positive to negative, and at 5/2. So it changed direction at t equals 1/2 and at t equals 5/2, and that's seconds. When does the particle reach the position 75? Justify your answer. We're going to have to use our calculator on that. I want to know, this is, I'm going to add a graph, not on the scratch pad. I'm going to add a graph, and I want to graph x of x. Oh, it doesn't like that. I don't think that it liked the fact that I used x of whatever. I'm going to go back over here, I'm going to scroll up, and I'm going to copy that right there. Copy, and I'm going to paste it in. New document. I wonder if it'll cancel it out. We're about to find out. Or if it carries it. Nope, it's dead. Curses. 4x to the third. I'm about to run out of time. 4x to the third minus 18x squared plus 15x minus 1. And I want to know where it reaches 75. Tab 75. I need to zoom settings. My Y-max needs to be like 100 maybe. And I can find my intersection. Analyze intersection. I know it said no calculator, but it was impossible to do without your calculator. 4.586. So that's 4.586, and that was seconds. And it's where x of t equaled 75. And we don't know how to do number 9 yet. So hold on to number 9. And we're going to stop the video right there because Madison just walked in.